All right, so I just did the Excel video, so that's how all these answers are in here. But let's say you want to use StatCrunch instead. So this is the weight of the bears. If I'm given a particular chest size, can I predict the actual weight? So I go to click on this little icon right beside the data. We don't want that. And then tell it to open in StatCrunch. La, 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 la. And so it actually moves my data in here. So I go to Stat, I go to Regression, Simple, Linear, because it's linear regression. My X variable is the chest size, my Y variable is the weight. That's pretty much all you have to do. So just, if you wanted to actually see a graph, you could click on things down here, but I don't care, I just need this information. So I click Compute. And you're going to see here that the negative 313.9, so that's the intercept right there. And then the 15.8, which is the slope, which is right there. All right. And so, so that's how we got this value. So then it asks to predict the weight of a bear with a chest size of 58 inches. The only way you use this equation is if it's a good prediction equation. How do we know if it's a good prediction equation? We look at our correlation coefficient and we compare it with a critical value. So our critical value, they said use a significance level of 0.05, and they give you the little table here. So I click on the table. There's 1, 2, 3, 4, 5, 6 bears. So I look at 6 under alpha 0.05. And I certainly see what I had for my correlation coefficient. If I can get it back here, 0.98 is certainly way larger than that. So when it is, okay, when you have your correlation coefficient is larger than the critical value, that's good. That says this is a good prediction equation. And so then what you do is you take where you see the X and you plug in 58. So do negative 313.9 plus 15.8 times 58. And you'll see that's how I got my predicted weight, which certainly is not very close to the actual weight of the bear. But that's how you use StatCrunch to find regression equations.